The last section of Chapter 7 is called the Law of Sines. So we're going to look at an example right away and see if anything that we've learned so far this chapter that we could put into play to figure out our answer here. So given triangle DEF, we want to find DE to the nearest hundredth. Okay, so I'm missing a side of the triangle. Now, here's the problem. This isn't a right triangle, so I can't use the Pythagorean theorem. Also, what we just learned with SOHCAHTOA, you need a right triangle as well. So I can't use SOHCAHTOA and I can't use the Pythagorean theorem. Why? Because again, I don't have a right triangle. So that's what it says here in red. Can we use basic trig or the Pythagorean theorem? Again, basic trig is SOHCAHTOA, and the answer is no, we can't. Why? Because we don't have a right triangle. Okay, but we can add one more formula into our bag of tricks here in order to be able to solve for that side DE. And what is that new formula going to be? It's something called the law of sines. So the law of sines is used when working with two sides and two angles of any triangle. So you need two sides and two angles. Okay, and again, it doesn't work with just right triangles. It's going to work with any triangle. So here's what it's going to say. The letters, the lowercase letters on top all represent sides. And on the bottom, you see we have the sine of each angle. So I have A over the sine of A is going to equal B over the sine of B equals C over the sine of C. You're only going to use two of those fractions. Again, really the point of putting all three in here is just to show you again, if I have angle A, the side that's directly opposite is lowercase a. If I have angle B, the side opposite is lowercase b. Angle C, the side opposite is the little c. Okay, so it's just to, again, show you that directly opposite the angle, that's how you would name the side with your lowercase letter. So it really doesn't matter which letters we use here. If we have the triangle above, we had DEF, so I could say D over the sine of D equals E over the sine of E. It totally doesn't matter the letters that you use, but again, little lowercase letter on the top, uppercase letter on the bottom. Again, that's a side on the top, that's an angle on the bottom. Okay, so now we're going to go back and do example number 1. So I'll scroll back up so we can see that triangle one more time, but I don't have room up there to really do the problem. Maybe I do. To the left here. Yeah, I could do it to the left. Okay, so let's look at what I have here. Okay, so right now I have two angles. I have angle D and I have angle F. Okay, and I know that I'm looking for DE, so I'm going to call DE X right now. Okay, so I have these two sides of the triangle, but only one of them is going to come into play. Obviously, I have to do this, use the X, because that's what I'm looking for. Okay, and again, that X is directly opposite the 91. And the other angle that I know something about is 22, and that 6.74 is the side directly opposite that. So I'm going to ignore that 16.55. Okay, so again, doesn't matter what letters we use here. So I have something about angle D and angle F. So I'm going to say little d over the sine of D equals little f over the sine of F. Okay, so little d, the side opposite angle D, is 6.74. And that's going to go over the sine of 22. And then on the other side, little f, the side across from angle F, is going to be that X that I'm looking for. And my angle there, that's directly opposite, is 91. So we're going to say that that goes over the sine of 91. Okay. So again, I have two fractions that equal to each other, so I can just cross multiply and solve. So I'm going to have X times the sine of 22 equals 6.74 times the sine of 91. Again, before I put this into the calculator, easiest thing to do is to get X by itself. So the opposite of multiplying by the sine of 22 is going to be to divide by the sine of 22. So those signs will cancel on the left-hand side. So I'll be left with X. And now when you go into the calculator, you can put this into the calculator all at once. Again, please make sure that you're playing along. I just don't want to waste the time in the video going into the calculator constantly. When you plug this into the calculator, again, put that numerator inside a set of parentheses. So 6.74 times the sine of 91 inside a set of parentheses, then divide by the sine of 22 and hit enter. So when you do that, you should get an answer of 17.99. Again, it said to the nearest hundredth. Nearest hundredth is 2 spots after the decimal. So there's my final answer there. Again, please make sure that you're getting that answer, because again, when it comes time to take the test, I'm not going to answer any questions about how to put things into the calculator. So please make sure that you're getting that answer. Okay, so now for our next one. In triangle ABC, the measure of angle A is 33 degrees, side A is 12, the measure of angle B is 43 degrees, and we want to find the length of the side of B to the nearest hundredth. So again, inside the star over on the right-hand side, if the problem refers to 2 sides and 2 angles, we're going to use the law of sines. Again, 1 angle, 2 angles, 1 side, and my second side. So I'm going to do A over the sine of A equals B over the sine of B. Okay, little a they told me was 12, and the measure of angle A is 33, so I'm going to have 12 over the sine of 33. And on the right-hand side, little b is what I'm looking for, and measure of angle B is going to be 43, so that's going to be over the sine of 43. So again, we will cross multiply to solve here. So I'm going to have B times the sine of 33 equals 12 times the sine of 43. And the same thing that we just did before, we're going to divide both sides by the sine of 33 in order to get our final answer. Those will cancel on the left, leaving you with B on the left-hand side. Again, when you chuck this into the calculator, please, please, please put that numerator into a set of parentheses. So 12 times the sine of 43, end your parenthesis, then do the divide by 33, and then hit enter. Again, this is asking to the nearest hundredth, so we need 2 spots after the decimal. So this is going to be 15.03. Okay. Triangle XYZ, I have the measure of angle Y is 87 degrees. Side Y is 14, side Z is 12, and we want to find the measure of angle Z to the nearest tenth. So again, I have an angle Z and an angle Y. That's 2 angles. Side Y and side Z, 2 sides. So I have 2 sides, 2 angles. That means I'm going to use the law of sines. So again, I'll use the letters that are in the problem here. So I know something about Y and Z here. So I'm going to say little y over the sine of Y is going to equal little z over the sine of big Z. Okay, so again, little y is going to be 14. I'll write it to the right here. So I'll have 14 over the sine. Angle Y was 87, so over 87. Little z is 12, and I'm looking for the measure of angle Z on the right. So I'm going to have the sine of Z here. Okay, so I'm looking for the measure of the angle. So eventually this time around, I'm going to have to do sine inverse. But let's cross multiply first before we get to that step. So 14 times the sine of Z is going to equal the 12 times the sine of 87. Okay, again, I want to get the sine of Z by itself right now. So right now I'm multiplying that by 14. So the opposite of multiplying by 14 is to divide by 14. The 14s are going to cancel, and now I have the sine of Z is going to equal 12 times the sine of 87 all over 14. Okay, again, a couple different ways to put this into the calculator. To me, again, I would do this right-hand side first and get a decimal. Okay, so I'm going to do 12 times the sine of 87 inside a set of parentheses, and then divide by 14 and get my decimal. Okay, and then you have to do the sine inverse to find the measure of the angle. Okay, or the other thing that you can do is you can put it all into the calculator at one time. So you can hit second, and then the sine key, because again, above that sine key is sine inverse. So I can hit second sine or second sine inverse, and then in a set of parentheses, I can do 12 times the sine of 87 and that set of parentheses divided by 14 and then 2 sets of parentheses like that. So if you type it in exactly like this, it should spit out your answer for you, and that answer should come out to the nearest tenth of 58.9. Again, please play along. Make sure you're getting those answers on your calculator. Okay, so the next two examples are just kind of real world examples where you could use the law of sines to figure out some missing information here. So we have a fire that breaks out only 80 feet from a ranger's tower. The ranger needs to run to the water tower to open the tower spout so that it will flood the area and put the fire out. How far is the run from his tower to the water tower to the nearest foot? So from his tower to the water tower, I'm looking for this piece of information right here. Okay, so again, law of sines, 2 angles, 2 sides. Now, again, I have to use this side because that's what I'm looking for. And when I look directly opposite that right now, I am missing that angle. Well, I have the other 2 angles of that triangle. So again, from way back when, we know that all 3 angles of that triangle have to add up to 180. So if I take 46 and add 28 to it, and then subtract that answer from 180, you should get an answer of 106. So that angle is going to be 106. Okay, so now here's the other thing. I don't know anything about this side right here that I just drew that arrow towards, but I do know that that one is 80 feet. So 80 feet is the one that I'm going to use. And again, if I look directly opposite that 80, that's going to be angle 28. So this angle 46, I needed it to find that other angle, but it's not going to come into play when I do my law of sines. Okay, again, letters don't matter here. So I'll say A over the sine of A equals B over the sine of B. So let's start with the 80 first. So I'm going to call 80 the little a. So I have 80. The angle directly opposite 80 is 28. So I'm going to have 80 over the sine of 28. B is that side that I'm looking for, and the angle that's directly opposite that is 106. So I'll have X over the sine of 106. Again, we can cross multiply here. So X times the sine of 28 is going to equal 80 times the sine of 106. And again, to get X by itself, the opposite of multiplying by the sine of 28 is to divide by the sine of 28. And again, they're cancel. And again, on that right-hand side, when you're chucking that into the calculator, just put that numerator into a set of parentheses before you hit the divide by the sine of 28. And when you hit enter, it comes out to approximately 163.8. Questions asking to the nearest foot. So when I round that to the nearest foot, it should give me an answer of 164. Again, can't stress enough, please make sure that you are putting these into the calculator to see that you're getting the same answers that I am. Okay, and here's our last problem of the day. Suppose 2 radar stations located 20 miles apart each detect an aircraft between them. The angle of elevation measured by the first station is 15 degrees and the second is 35 degrees. Determine to the nearest hundredth the altitude of the aircraft. Remember, altitude is height. So really what they're asking me to do here is to find that little dotted line that goes from the plane straight down. So that's what I need to find. Now, just be careful. This 20 miles is not part of the little triangle on the left or the little triangle on the right. So right now, again, even though the left triangle and the right triangle are both right triangles, I don't have any sides of those little triangles. So the first thing I need to do is I need to look at that entire red triangle because 20 is the entire side there between your 2 radar stations. Okay, and I have 2 angles of that red triangle right now, and I have this one side. Okay, well, again, one thing that I'm going to have to find first, that 20 miles is directly opposite this big angle right there. So I'm going to have to find that big angle first. Hey, how am I going to do that? Again, the 3 angles of the triangle have to add up to 180. So if I do 15 plus 35, I'm going to get an answer of 50. Take 180, subtract out 50. that little angle up there, that big angle up there, is 130 degrees. Okay. So the next thing that I'm going to do is I'm going to find that distance there from this radar tower on the left up to the aircraft. Okay, so now in order to do that, now I am going to look at the triangle again, the big red triangle, but again, I have now my law of sines. So I'm going to do my, let me do y, sorry. I forgot my thing on top. Since I have y in the problem, I'll do y over the sine of y equals, how about x over the sine of x? Okay. So here is y, little y, that's what I'm looking for. The angle directly opposite that, if I go straight across there, is going to be 35. So I'm going to have y over the sine of 35 is going to equal the other side that I know something about is that 20. So that x is going to be 20, and the angle directly opposite that is 130. So I'll have the sine of 130. Okay, cross multiply and solve. So I'll have y times the sine of 130 equals 20 times the sine of 35. To get that y by itself, we'll divide by the sine of 130. And again, when you put that into the calculator, just please make sure that you're putting that top into a set of parentheses, and eventually you should get an answer of 22.94. So this piece right here is 22.94. Okay, now I think I have enough information where I can use SOHCAHTOA here. So I'm just going to clean up this picture a little bit and get rid of those and that right there. And I'm going to highlight now the triangle that I'm going to talk about. I'll talk about this left triangle right here. Okay, so that left triangle right there, again, altitude is always perpendicular. So I definitely have a right angle there. The angle that I know something about in this triangle is 15. I am looking for, I'm going to call that x. I'm looking for that height. Again, this 20 is not part of that purple triangle. It's part of the red triangle. So with relation to 15, that x is the side directly opposite. And that 22.94 that I just found was my hypotenuse. So again, if I want to use SOHCAHTOA now, I can. And opposite and hypotenuse is going to be my sine. So we'll do the sine of 15 equals the side opposite, which is x over 22.94. So again, when I cross multiply here, I'm going to have x equals 22.94 times the sine of 15. And again, when you chuck that into the calculator, it's asking to the nearest hundredth. So we'll round to 2 spots after the decimal. You should get an answer of 5.94. And that's your final answer there.